There we go. And we are starting the live stream. And I see that two people are watching it, and I think they might both be me. So this is awesome. I hope I'm not too hard on myself. Oh, I better shut off the sound on this. We are starting the live stream. And I see that two people are watching it, and I think they might both be me. So this is awesome. I hope I'm not too hard on myself. Okay, so the purpose of the stream is to use everybody as guinea pigs. I'm trying out StreamYard, which I like because it's all browser based, and we're going to be sharing a writing tablet on the screen right away and doing a derivative, and it probably won't take a lot of time unless there's like a whole lot of questions from the one person who's watching, who I think might be me. Okay, so let's I'm Adam with my hat. Let's bring up this screen here. That is way too small. We can try this. There you go. There you go. And that's kind of good. Okay, so what are we doing? We are looking at a function. And what is that function? I guess I'm going to need to bring up the other thing here. Alrighty. Can I bigify this? Let's bigify that. Okay, so I've got to remember what we were even doing. There's my pen. Yep, and yep. And that looks good. Okay, so what's our function? Our function, well, I guess we'll call it f of x. And it's a compound function, eh? So we're going to do sine of x all to the power of the log of x. Okay, so we've got a function of a function. Okay, and what we're looking for is the derivative of that function. Okay, and so the way I'm going to do it, which might cause some people some upset, but I kind of do things, sort of a whacked out way, and maybe it'll help and maybe it won't. I don't know. What I'm going to do is, because we've got two functions here, I'm going to, for a little bit, treat them as separate. Okay, well, I've got to treat them as separate, but what I mean is I'm going to treat this x as if it's, say, x bar, and I'll just treat this x as x. Okay, they're all x, but I want a way to separate them, and I've used colors before, but I find that can get confusing. Okay, and the reason I'm doing it that way is because what I want to do is I'm going to do partial derivatives. So I'm going to do d by dx of all of this. Oops, it's lagging a little bit. Partial derivative, and add that to the partial of d by dx with the little bar. So this is my experience here. There's a little bit of lag when I use this, and it's because I think I'm demanding lots of resources here. Okay, and so again we got sine x bar, just take my time maybe, to the power of the logarithm of x, plain old x. All right, so we've separated. We've got two different ways of talking about x. Okay, so that I can separate and do the derivatives separately. Okay, because let's look at we've got x bar down here. Okay, so we're treating x bar as if it's a constant, so sine of x bar. So this is the same as if we were doing d by dx. Okay, really got to get used to this. Like d by dx of just some constant to the power of, I don't know, some function. I'm just going to say some function, u of x. Okay, u of x. That is an awful u of x. Hang on here. There we go. There we go. Play nice. Okay. And what if we were going to do that? Well, we know that that is going to be the same as the original function. Just slow down, Adam. Times the log of the exponent. That's log of 2. Okay, and I gotta put the other times here. Times the derivative of what's up here. So u prime of x. Okay, so that's what we're going to do with this part. Okay, because we're taking the derivative with respect to x without any bar, so we're treating sine of x bar as if it's just solid constant, and the log of x, that's our function. So we're doing it like this. So what happens when we do that? Well, we get okay. So notice how the two all stay the same. So first of all, let's just write out. We do the part where the function stays unchanged. So sine. Come on, be good. X bar to the power of the logarithm of x. Okay, so we did that part. And then we take the logarithm of the base. So that's just the log of the sine of x. Next time I might do a wired connection, and maybe then I won't be fighting so much for bandwidth. This computer also isn't known for its guts. Okay, so we did this part, and then now we've got to multiply that by the derivative of what's up here. And what's the derivative of the log of x? It's 1 over x. So actually, this part here, we can just put it all over x. Okay, and so that's taken care of this part of our partial derivative. Okay, and now let's move on to this part. And I'm going to erase this business here so that we're not getting too busy. Come on, erase, be good. It goes away in lumps here. We'll rename this to Adam Erases Stuff. Okay, back to that. Okay, so now we're gonna look at this part, and I've gone and really messed up by putting the bar. Oh no! Yeah, the bar is still here, but now we're taking the derivative with respect to the bar. So this is the function, and this is the the constant up here. Okay, so now we've got something of the form of, I mean, the power rule type of stuff. Okay, so let's say we had, just as an example, let's say we had a 5 up here. Okay, and we want to take the derivative of that. Okay, so to do that, we would bring the 5 down here and put x to the 5 minus 1 is 4. Okay, that's what we would do. All right, so we're treating now sine. We're treating sine x. We're treating the logarithm of x now as if it's the solid thing. Okay, we're not treating this like an exponential. We're treating it like a polynomial. So here we go, and let's hope this is right. So we'll so to do this one, come on, be good. What do? There's our, come on, sine of x bar. I'm being inconsistent about when to put the bar here, I think, and that may be a little confusing because it's using it as a mnemonic. It all ends up being x, but I'm using it as a mnemonic to make sure that I differentiate the right parts. If you're doing multivariable calculus, you've got it clearly marked as there's an x and there's a y. And so what I'm doing is a little bit unkosher, but it works. It's single variable, but I'm treating those single variables as if it was multivariable. So we got, what do we got? So we got sine x, and then what do we do up here? We subtract 1 from the exponent, log of x minus 1, and we bring down the exponent, log of x. There you go. But now we also have to think about chain rule, which didn't come out when we used this because we just used an x. But if this thing that's to the power of 5, if it itself is a function, which it is here, then we also need to multiply by the derivative of that function. So this whole shooting match gets multiplied by the sine of, sorry, not sine of x, but by the cosine of x. And you know what? I'm going to put it so it doesn't get crowded. I'm going to put it over here. All right. And there, we've done that part. And so all that gets added together. And we're done. We might be able to simplify this a little bit. Like if we multiplied both sides here by x, so we got x as a common denominator, and then maybe we could factor out this sine x to the log x minus 1. But I don't know that it ends up, it depends on what we're planning to do with it, how useful it gets. And it could get useful if we wanted to go and take this first derivative and actually do something with it. Okay, but we're not going to get that complicated today. Let's take a look at what this looks like more legibly on Desmos. So for that, we need to go to Desmos. So hang on. Okay, what have we got? Desmos, yeah. Okay, so let's go and look at Desmos. Stop screen. Oh, it's me again. Oh, my one viewer. Hi, one viewer. Glad you could join us. And let's share, because it's nice to share. Let us share the Chrome tab that has got the Desmos graphing calculator. And you should be able to see that forthwithly. Okay, so here's our Desmos graphing calculator. And this looks like a neat function, and it's periodic, but you can't see it. You can see me. Have we got it set up yet? How long is it? Hang on here. Got to make sure you can see what I want you to see. Yeah, okay, you got it. So let me take a closer look at this here. Yeah, so you can see we're looking at a periodic function. Hey, the zeros are at multiples of pi, and it's all positive. Okay, because we're dealing with real numbers here, right? So yeah, so when is it 0? Well, it's at pi and 2 pi and 3 pi, all the places where the sign of x is 0, and we've got this all to the power of the log of x, and so that limits what can happen over here, because the log of x, 0 is not defined. Well, it approaches infinity. Eh? So I mean, that would be another exercise to take a limit here to show, because as this gets closer to 1, or sorry, as sine x gets closer to x gets closer to 0, sine x gets closer to 0, but the log of x gets bigger and bigger. Is that right? Bigger because x e to the power of what gives me a tiny number. Yeah. It's going to get bigger and negative too, I think, isn't it? So yeah, I'm having a hard time thinking about this off the top of my head here. It's sort of dancing. What was it? Okay, dancing on demand. Like hot water on demand. So let's look at the derivative that we came up with, and I got to go back and forth a little bit here so I can see this. So so let's see, what was our first part here? Hang on here, it's not moving. There we go. Okay, so we've got the log of sine x times sine x to log x all over x. Let's try that. Okay, so we've got the log of sine x times sine x to the all to the power of log x minus 1, and double check here. No, it's not log x minus 1. That's another one. I'll just all to the power of log x, and then it's all over x. So beyond you. Okay, but this is all over x. Okay, I'm going to simplify this by calling this g of x. So that first half of everything is g of x. And then I'm going to call h of x the other part of the derivative. Just testing this to see how much sense it all makes. So let me go back. So now we've got the log of x times sine x times the log of all times cosine x. Okay, so log of x times sine x, log of x minus 1. Okay, yeah. So now we've got the log of, already going backwards here, log of x. Bring down the exponent. Okay. Times sine of x to the power of log of, okay, this is where we want to make sure that we get this all right. Log of x minus 1. I sure hope this works. I do have it written down someplace where it does work. Okay, and all of that gets multiplied by the cosine of x. So back to Desmos. All that gets multiplied by the cosine of x, and that's h of x. And isn't that beautiful? Okay, so this is one of the partials, g of x, and the other partial is h of x, and it's all x. It's all x. So now I'm going to sum these two, because the full derivative is the sum of the two partials. And let's hope this works. Oh, okay, that looks good. That's good. That looks good. That's looks a little off though. What in the world is going on here? So there's h. Oh yeah, there's h. Then there's g. Okay, and here's the original. Let's do this a different color here. I don't know. Let's make it blue. Okay, nice and blue. All right, and so now here, this is all the derivatives. A little concerned that it doesn't seem to fit entirely, but I'm going to silence these, because theoretically this thing here is the derivative, and it looks right. So I'm also then going to say, I don't know, m of x, and equals, and then I'll get Desmos to do the derivative for me. dx of f of x. And there you go. Okay, that's what we want to see. Okay, when we get Desmos to do the full derivative for us, and really we need to make that a different color, green. When we get Desmos to do the full derivative for us, it should be right on top of our calculation of the derivative, which is lovely. So just a final word, that is not what I wanted to do. Hang on here. 250%. Oh, okay. I just kind of wanted to zoom in a little bit fairly. Like, there we go. Let's check it out. So you'll notice how this derivative, the derivative is the green, and the parent function, or whatever you want to call it, is this blue up here. You notice how there's two zeros here. So you can see it would be really fun, I mean, trying to graph this by using derivatives, like we did with the sine of x, where I did the sinh of the log of x, another video. It would be, because look at these zeros. I mean, that zero, that looks like that might be fairly easy to find there. That's pi by 2. But what is this zero here? I mean, that would be a fun exercise. So what's going on here? We've got a 0 here and a 0 here. So what is it doing in between this 0 and this 0? It's like these are inflection points, or is that a minimum, and that's a maximum maybe, and then it goes down. So it's, yeah. Here, this has got a nice innocent 0 right at the maximum, and same here, a nice innocent 0 right at the maximum. But this is an interesting little baby right here. Anyway, we could talk about lines, but I've done everything I came to do, and thank you for watching. And I'll just answer some comments now. There's no comments. Okay, that's fine. I'm going to make a comment. I will make a comment. So, wow. Love the video. Look, there's a comment from Math Adam. I think I'll highlight it. Okay. Thank you. We won't drag this on any further. Bob is your uncle. Please subscribe for more content. Let me know if you'd like to see stuff in live streams, if you'd like to see other different kinds of content that we've got. There's playlists and such. And I'm going to say adios for now. Cheers. And thank you for letting me into your telephone or whatever it is. Bye-bye. End broadcast.